So I'm here to introduce Corey Fleischer. He's a retriever with a BS and an MS in mechanical engineering from UMBC. As a student, he received an undergraduate research award to conduct research with Professor Mark Zupan in the Department of Mechanical Engineering. He joined Lockheed Martin after graduation and rose through the ranks to become a senior mechanical engineer. In 2013, Mr. Fleischer was chosen to be part of Discovery Channel's The Big Brain Theory, Pure Genius, where he showed what a UMBC retriever can do by winning the competition. More recently, he became founder. Thank you. He became co-founder and now serves as manager of the Foundery, a really awesome makerspace in Baltimore City. I was fortunate enough to visit just a few weeks ago. Please welcome Corey to give his GridX talk, Building Founders the Old-Fashioned Way.
Thank you. All right, thank you. So I'm Corey Fleischer, co-founder and general manager at the Foundery, and I'll be talking about Makerspaces and hardware incubators. So one of my favorite startup stories is Harley-Davidson. So in 1903, Harley-Davidson started in a 10-foot by 15-foot shed where two childhood friends built motorcycle engines and motorcycles. And they put together very crude prototypes. The motorcycles that they built and sold looked like motorcycles built in a shed. So they quickly, from 1903 to 1912 though, grew that business, outgrew their shed, and grew into a 6-story headquarters. Because all it took was a working prototype to be able to demonstrate the power and effectiveness of their motorcycles, and customers were lining up, including the US military. So I also like to build things that I can drive around. When I was at UMBC, I was very lucky to be a part of the UMBC Mini-Baja team. So during this program, me and fellow students designed and built these single-passenger off-road vehicles, and we competed against other colleges from around the country. And during this experience, it was a very powerful experience because we were learning textbook knowledge in classrooms, but at the same time, we were learning how to weld, we were learning how to machine parts out of steel, and we were learning firsthand how to build things. So we were not only doing the textbook analysis and design work, but then we were building these components ourselves. After UMBC, I went on to work at Lockheed Martin, and immediately I was working on really awesome projects. I got to work on missile launcher systems and crew transfer systems, which were helping people get from the ocean surface 4 stories up to oil platforms for the typical work days. And while working on these projects, I felt that I was ahead of the curve compared to the other engineers my age. A lot of engineers were coming out of school with a lot of textbook experience and classroom knowledge, but didn't have a lot of hands-on fabrication. It was actually rare to find engineers who could actually build things with their hands. So these are some of the projects that I build. You can see I love to build things that I can drive around, right? It's my taste. Actually, in the upper left corner, the mini trike, and the lower right, motorized bar stool, I built those at UMBC in the Mini-Baja shop while I was a student here. All these projects here were built outside of classrooms, outside of the workplace. These are stuff that I did in my own time just because I love to build things. So I'm considered a maker, right? Maker is a kind of a trendy term to describe people who build things. I don't really like the term because I feel that long ago it was more popular to build things. I remember my grandfather had a basement filled with woodworking equipment, and he never considered himself a maker. He just made things. Today, I still think it's in our genes to want to build things. If you look at kids with Legos, most kids grew up, and still today, I encourage my kids to be curious and take things apart if they want to see how things work. Unfortunately, iPhones and iPads don't have screws these days, so kids really can't take those things apart. But right now, it's a great time to be a maker and to be into building things. In the past 10, 20 years, there's been a revolution in the type of tools that we can use as makers. Right? We have 3D modeling software. So now, and there's free versions for households where kids can learn Google SketchUp, which is a free 3D modeling software. So you can design things in 3-dimensional virtual space on a computer, rotate things around, test fit the components. We also have, in the upper right corner, microcontrollers. That's an Arduino. It's a microcontroller the size of a credit card, and you can use that to program robotics and to build robotic projects. In the lower left, that's an example of TIG welding. Manufacturing tools are going through a revolution. Welding systems used to be the size of refrigerators just 20, 30 years ago. Now they have welders the size of a lunchbox. So it's very approachable to to everyday people. In the lower right is an example of computer-aided manufacturing tools. Now we have 3D printers, CNC routers, and things that are becoming at a price point where people can, almost every household can afford 3D printers these days, and you can design and build something in your living room that 20, 30 years ago people couldn't build in a workshop. So not only is it a great time to be a maker because of the access to tools, but also it's becoming popular, right? I tell my wife that it's cool to be a maker these days. My skills, my ability to design and build things got me on Discovery Channel for The Big Brain Theory, which is a competition-based reality show where they had 10 engineers, inventors, and scientists, and we had to compete to build things. And if it wasn't for the popularity of that maker culture, Discovery Channel would have never, set aside the funds to launch the show. So while I was on the TV show, I actually met a fellow contestant, Guy, who ran a makerspace in Boston called Artisans Asylum. So a makerspace is community access to tools and training. That's kind of the tagline. What a makerspace is it's kind of like a fitness center. Instead of, gyms have advanced exercise equipment and they teach classes like yoga, things like that. Well, Makerspace is the same principle, but you have access to tools. So members can come pay a monthly membership rate and have access to industrial-sized tools and also classes on how to weld, how to use 3D printers, and things like that. So up here on the left is an example of something that came out of the Makerspace Artisans Asylum in Boston. A group of members there built a 4,000-pound hexapod, which is basically a walking robot that fits 2 passengers. The 3Doodler pen, which is a 3D printing pen, came out of Artisans Asylum, and that went on to raise $1.5 million on Kickstarter. The Square, which is a hardware startup that allows people to accept credit card payments through smartphones or tablets, that came out of Tech Shop, which is a makerspace in San Francisco, went on to raise $10 million in capital investment. So when I found out about Artisans Asylum up in Boston, I was jealous that there was a space in Boston where anyone could go and have access to these tools to build any cool project they could think of. I knew that there wasn't one in Baltimore, and I wanted one, not only for myself, but I believe there's a lot of people in Baltimore could benefit from this space. So I teamed up with Jason Hardebeck in Baltimore, and we started the Foundery, which we started in a 2,000 square foot row house in Central Avenue. And this building, we considered our MVP, our minimal viable product. So it was a 12-foot wide warehouse where we taught welding classes and CNC laser engraving. And our goal there was to see if there was more makers in Baltimore that were interested in a space like this. So we threw it out there, and this was definitely a minimal viable product, right? There was no heating, no air conditioning. The bathroom looked like something out of a horror movie. But the welding classes we threw out there, we had about 5 or 6 welding classes a month, and we were selling out weeks ahead of schedule. Our CNC laser classes were always selling out. We always had members coming in during our open hack nights where we're encouraging people to come in together at the same time to work on projects. And it really validated this concept that Baltimore needed a makerspace. So in 2015, we partnered with Plank Industries here in Baltimore, and we grew into a 19,000 square foot facility. So this is our current facility. We have industrial grade tools. We have an elaborate wood shop, metal shop, a great welding area. We do powder coating. We have CNC manufacturing tools. Pretty much our goal here is to have anybody walk in with a hand sketch on a napkin for a product or an invention they want to build. And with our tools and classes, be able to walk out with a polished, professional-looking prototype. So hardware startups are nothing new. There's a lot of well-known companies that started in garages. Apple Computer, Steve Jobs and Steve Wozniak started, with the early Apple computers. They were learning woodworking skills to build wood cases for these computers. Tony Maglica, who created Maglite, put a down payment on a lathe to start prototyping his flashlight, which he went on to, they were bringing in over $100 million in 2003. Yankee Candle, started by a 16-year-old in a garage and went on to, it was recently sold for $1.75 billion. And this is what we want. We want the Foundry to be these garages and sheds for startups, right? We want people with ideas and prototypes, or people with an idea that need a prototype to come to the Foundry. Not only do we provide access to tools and training, but one of the best values added that we provide are the access to the community. We have mechanical engineers working next to electrical engineers. We have people that are on their second or third product that they're developing who serve as mentors to other people starting out. We have people who have written patents on their own so they can help out kind of direct these younger entrepreneurs with how to protect their intellectual property. So just a couple examples. With our mission set out, we're already kind of seeing this come to fruition. Jamie Hodges here came up with an idea for an improved leveling dock hold down. It's basically a system that is underneath most loading docks. He'd been selling them for many years, and he had an idea to improve upon a 20-year-old design. So 4 years leading up to the Foundry, he had been working, and he was designing parts, sending it out to manufacturing facilities, and getting parts back. And he found out about the Foundry and knew it was exactly what he needed. So he was one of our first members, and in 4 months, he says that he accomplished more than the 4 years leading up to that. Instead of designing parts and sending out drawings to a manufacturing place and then waiting for them to come in, seeing if they fit right, he's able to do the CAD work, cut the parts out on our water jet, in the same day, test fit them onto his system, and if it needed adjustment, he could tweak his model and go right back to the water jet. He wasn't waiting 6 months for iterations. He was doing design iterations in 2 days. Now Jamie is doing small-scale production at our facility. He's actually putting them together, welding them, powder coating them, boxing them, and then delivering them to local customers in Baltimore. Another great example of our success story is Nick Carlson here. Nick Carlson owned a landscaping company, and he was timing his employees, and he found out his employees were spending more time unloading mulch from the back of pickup trucks onto wheelbarrows than they were actually using those wheelbarrows to disperse the mulch around properties. So he came up with an idea for a mechanical system to pull mulch from the back of the bed of pickup trucks and then spit it out the side onto a wheelbarrow. And he leveraged pretty much every resource we had at the Foundry. He took our 3D modeling classes, our water jet class, and he reached out to other members that were experts at 3D modeling. So in the upper right is a detailed rendering of a 3D model that he actually paid another one of our members to do for him. And then he paid another electrical engineer at the Foundry to do all of his wiring and electrical design. And now Nick has a working prototype that doesn't look like it was built in a small shed. I mean, his prototype looks polished, looks like it came out of a factory line. And it's turnkey, so when he goes to demonstrate to a customer, he pushes a button and it spits out 5 pounds of mulch a second into a wheelbarrow. So he's using that to generate sales. And he's already looking at warehouses, and pretty soon he'll be doing his first production run of the Mulchmate. So anyone that comes into the Foundry, I want them to know that failure is an empowering way to learn, right? When people set out to create a prototype, they're going to fail. So when you fail, you build something that doesn't work quite right the first time, and then you go back and redesign it and you get it to work, you're now a subject matter expert for that system. So I tell everyone to fail faster, right? The best way to succeed is to learn all those lessons as quickly as you can. So prototype fast and solve one problem and get to your next failure. Also, strong, successful companies have humble beginnings, right? There's a lot of quick, popular startups like Uber and Facebook that kind of seem to pop up overnight. And that's what most people think of software when they hear these fast-moving startups. But there's a lot of hardware startups out there, and a lot of them started in sheds and garages. And it takes special people with a special product to become a successful hardware startup. So access to tools and access to the mentorships and community shouldn't be the biggest roadblock. Thank you.